So what we're working on today is our exponential growth word problems. Bless you. So thinking back for a second, if you remember, with our graphs, our exponential growths were our increasing ones. So then your exponential decays are your graphs where they decrease. So those are our growth and our decays based off the graph. So what we're going to be doing now is we're going to be dealing with our word problems where you won't really need to graph it. You're going to have a formula to use. So our formula for today for our growth is y equals a times 1 plus r to the x power. And then our exponential decay formula is the same thing, but instead of 1 plus r, it's 1 minus r to the x. So it's the same formula, it's just growth you're adding, decay you're subtracting. And as you see in my little note there, you guys will need to memorize those two formulas because they give you an exponential growth decay formula on your Regents reference sheet. And when we look at it, I'm going to show you, no, trust me, just memorize these ones. Your lives are going to be so much easier. So what these all stand for, A is your initial value. So that's what we start with. If we were graphing it, where is our initial value on a graph? It's where you start, also known as our y-intercept. So your A is also your y-intercept if we were graphing. R is your rate. We have to turn it into a decimal form. They give you the percentage form. We want to use your rate as a decimal, so we've got to change it. And then X is number of times it happens. And then Y is just your answer, what your new amount is. We don't usually know that. That's what we're generally trying to find out. So let's take a look at our first question. We have Josie invested $500 in an account earning 5.25% annual interest. Determine the amount in her account after 18 years. So let's go through what we know. A, as I said, is our initial value. So how much did she start with? So A is 500. R is her rate. So what they tell us is it's 5.25%, but we have to change our percent into a decimal. Does anybody remember how to do that? Jordan? Move your decimal 2 places to the left. So that means I'm going to fill in the space with a 0. We're really using 0.0525. That's our 5.25% as a decimal. So then our X, since it's annual interest, that means she earns it once a year for 18 years. So X would be 18. This is happening 18 times. So now would this be a growth or a decay? Matt? A growth. Yeah, so we're going to use a plus sign for this. This one's going to be a growth problem. So let's write over here our formula first. Again, the more times you write it, the more it's going to help you remember it. So y equals a times 1 plus r to the x power. Let's fill in what we know. So our a is 500. 1 is a 1. Our r is 0.0525. And our x was an 18. So what I want you guys to do first, and I will explain it as we go as to why, I want you to combine these two things in your parentheses first. So 1 plus the 0.0525, what does that give us? 1.0525 to the 18th power. So then under your blank screen, not in your y equals, but your regular screen where you do your calculations, just type in your 500 parentheses 1.0525 to the 18th power, and that's going to give us our answer. Yes. Now this is kind of a problem where they're not going to tell you where to round, but we're dealing with money. How many numbers after the decimal can we have? 2. So that means I'm going to round to the 3, but this 7 makes the 3 turn to a what? 4. So it would be $1,255.94. So to answer the question, Josie will have $1,255.94. That's it.
No, I'm just saying that's a really good question.
So now, again, to make a connection for you guys, when you're given an equation, a lot of times they'll give you an equation like this already, and they'll ask you if it's growth or decay. The way you can tell is you have to look at this number in the parentheses. See how this is a number bigger than 1? Not by much, but it's bigger than 1. That makes it a growth. The fact that that's greater than 1 makes that a growth problem. So when you're graphing it, it's going to be a curve that looks like this way, where it's an increasing graph. All right, let's take a look at our next problem. So we have the population of a town is decreasing at a rate of 2.5% per year. If the population in the year 2000 was 28,000, what will be the expected population in 2015 if this rate of decrease continues? So let's make our little chart of the numbers we need to know. So what is our A? How many people do we start with? 28,000. Perfect. Our R would be 0.025. Again, we got to move that 2 places to the left. And then our X? It would be 15, so we're going from 2000 to 2015, so our X would be 15. Yeah. So since this is decrease, are we going to use growth or decay? Decay. So A times 1 minus R to the X. And then we'll plug in our numbers. So 28,000, 1 minus 0.025. To the 15. So again, figure out the stuff in the parentheses first. So do your 1 minus your 0.025 first. What do we get? 0.975. Now you see this time how this number is less than 1? That's our hint that this is decay. That number is less than 1. All right, now go ahead and type that whole thing in. 28,000, parentheses, 0.975 to the 15th power. Is that what everybody got? Okay. Here's the tricky part with our exponential problems. If you have a decay problem like this, dealing with population, so you're dealing with people or with animals or anything like that, population decrease always round up. We can't have 0.57 of a person. Doesn't happen. You can't tell me they're missing limbs. They still count as one person, even if they have missing limbs. I don't count as 0.5 of a person right now because I have a baby in the belly. It doesn't work that way. I'm still one person. So what happens is, let's say here's my people. No, I'm not. Still one person. So let's say we're decreasing. So here I'm taking away this person and I want to take away another half of a person. And as we just said, we can't take away that half. So I can't take away another half and round down because now I've taken away too much, which is why they always say you have to round up and bring the rest of that person back. So this answer would be 19,153. People in 2015. Now, if it were the other way, if it's a population increase, which way do you think you would round? Down. Population increase, always round down. Because again, if you're increasing, you have that point of a person, you can't create that last part of the person to round up, so you always round down. That's the only tricky part with those ones, is remembering which way to round. Let's take a look at our two on the back. So we have the current student population of the Brentwood Student Centers 2000. The enrollment at the center increases at a rate of 4% each year. To the nearest whole number, what will the student population be closest to in 3 years? So what is our A value? 2,000. What is our R? 0.04. And then our X would be 3, because they want to know in 3 years. So after each year, it increases once. So would this be growth or decay? Growth, because the population is increasing. So it'd be A times 1 plus R to the X power. So we'll plug in our numbers, so 2,000 and then 1 plus 0.04 to the third. Again, we'll add the stuff in our parentheses first. Which would give us a 1.04 inside of our parentheses. And then go ahead and type it in. 2,000 parentheses 1.04 to the third. So this was a population increase. So what would I actually round it to? 2249. So there will be 2,249 students. Always need our sentence there. And then our last one, the value of a car purchased for $20,000 depreciates at a rate of 12% per year. What will be the value of the car after 3 years? So let's make our little list here. What is our A value? 20,000. Our rate would just be 0.12. Because right now, the decimal is after the 2. If I move it 2 places to the left, it's in front of the 1. No extra space this time. Yep, but if I move that 2 places, I got a space that I got to fill in with a 0. Okay. And then our x would be a 3. So is this growth or decay? Decay. That word depreciates. That gets a lot of kids, but that starts with DE just like decay starts with DE. That's a decay problem. So we want the a times 1 minus r to the x power. Oops, I didn't mean to put a in there again. So we got 20,000, 1 minus 0.12 to the third. So when I subtract, what's our number inside our parenthesis? 0.88. So 20,000 times 0.88 to the third. What do we get as our answer? No, this is money. Can't I have cents in money? Yeah. So we don't have to round this one. The car will be worth $13,629.44. No rounding for that one.